Hey guys, so we're going to take a little break from the chapters in the book and talk a little bit about factoring. Some of you saw it in Algebra 1 and some of you did not. It's a really important skill moving forward. So we need to make sure that we're all on the same page and we can all factor really well. I'm hoping to only spend 2 classes on it, maybe take a quiz, and move on from there. There are 3 types of factoring. The first type is GCF, greatest common factor. We're going to do that mostly today. And you always look for this first. When factoring, you always look for a GCF first. 2 is the difference of perfect squares. Remember, perfect squares are things like 1, 4, 9, 16, 25, 36, and so on. Or x squared, y squared, x to the 4th. Any variable, this is kind of important. Any variable with an even exponent is a perfect square. And we'll talk about that on the next screen. That's really important to understand. And then the third type, I'll just go right down here, is trinomial. We'll get to that on the next video. Today I'm just going to talk about GCF and difference of squares. Okay, so let's first talk about why any variable with an even exponent is a perfect square. Think about y to the 3rd times y to the 3rd. You know that when you multiply variables, you add exponents. So it's y to the 6th. But this could be written as y to the 3rd squared. So it's a perfect square because it's something times itself. So for instance, what is the square root of y to the 18th? It is y to the 9th. It's half of the exponent. Because y to the 9th times y to the 9th is y to the 18th. A lot of people mess this up when the exponent is a perfect square. They want to say that the square root of y to the 16th is y to the 4th. But that's not true. The square root of y to the 16th is y to the 8th because y to the 8th times y to the 8th equals y to the 16th. This is a really important thing to understand. So please watch it again, rewind it, do whatever you have to do to make sure you understand why this is true. Okay, but now we're going to talk about GCF. You've all learned about GCF when you talked about fractions in elementary school, but now we're going to talk about GCF by factoring. So, if I gave you this problem and told you to distribute, you would all tell me that the answer is 7x minus 14. What we do in factoring is we take this and go backwards and get this. So, let's say we have 3x squared plus 9. What is the greatest common factor between 3x squared and 9? Well, the greatest common factor is 3. So now I have to divide out a 3 from each of these terms. When I divide out a 3 here, I'm left with x squared. When I divide out a 3 here, I'm left with plus 3. This is your answer. This is factored because you're writing this binomial as the product of 2 factors. Here's one factor, here's another factor. The definition of a factor is a number that multiplies to get you a product. So for instance, the factors of 10 are 2 and 5. The factors of, that's a times. The factors of 3x squared are 3 times x times x. So that's what a factor is. So we're showing a binomial or a trinomial as the product of factors. Alright, let's do some more examples. The only way to get really good at this is to do a whole bunch of examples. 5x minus 15. I always say take out a 5. Factor out a 5. That's what's left. It gets a little bit harder when we start dealing with things like this one. Because now you have to talk about the GCF of the numbers and the GCF of the variables. So the GCF between 8 and 24 is 8. And the GCF between x to the fourth and x squared is x squared. The reason is, if you think about x to the fourth, that really means x times x times x times x. When you think about x squared, that means x times x. So how many x's do they have in common? That's where the c comes in, common. Well, they have 2 x's in common. So x squared is your GCF. And when you pull out 8x squared, you're left with, well, when I divide 8 out of 8, it becomes 1, and I don't write that. And when I divide x to the fourth by x squared, when I pull 2 out, I'm left with 2 inside. And then minus 3. Okay? Progressively getting a little bit harder. 5x to the fifth plus 10x squared. You can take out 5x squared and you're left with x to the third plus 2. And then we have 2x squared plus 2x minus 8. GCF here is 2. We're left with x squared plus x minus 4. Hopefully that makes sense. Now let's get a little bit trickier. What about if we have, oh, what was my last number? I like to number these. Number 7. We like to have, or sometimes we'll have more than 3 terms. In order for a factor to be common, in order for it to be a GCF, it has to appear in every single term. So what is the common factor between 6, 12, 24, and 30? Well, 6 is the common factor. X to the 8th, x to the 6th, x to the 4th, x squared is common. So you're left with x to the 6th plus 2x to the 4th minus 4x squared plus 5. Sometimes the numbers, the coefficients, won't have a common factor. That's okay. But the variables do. There's 5 x's here and 1 x here, so x is a common factor. And there's 1 y here and 2 y's here, so y is a common factor. When I divide out xy, I'm left with 9 x to the 4th minus 7. I took out the x and I took out 1y, so I have 1y left. Now the nice part about this is you should be able to distribute and get what you started with if you did it correctly. If I distribute this, 1 times 9 is 9, x times x to the 4th is x to the 5th, y minus 7 x y squared, which is what I started with. Let's do another one. X to the 5th, y to the 5th, plus x to the 4th, y to the 3rd, plus x to the 3rd, y to the 3rd, minus x squared, y squared. So, go through and see if they all have x's, which they do. Do they all have y's? Yes. So you know you at least have xy as a common factor. Now, how many x's? 5, 4, 3, 2. So they all have 2 in common. 5, 3, 3, 2, they all have 2 y's in common. When you take out 2 x's, you're left with 3. When you take out 2 y's, you're left with 3. When you take out 2 x's, you're left with 2. And when you take out 2 y's, you're left with 1. Sorry for that silence there. I was getting ready to sneeze. Now this one's tricky. When you take out the whole term, you really get a 1. Because remember, we're really dividing. So when you divide this by x squared, y squared, you're left with 1. So, number 10. Let's do negative 5a to the 3rd, b to the 4th, plus 10 a squared b cubed minus 15 a cubed b squared. So here you could take out a 5 or a negative 5. It doesn't really matter, but the common rule is that we want the first number in the parentheses to be positive. So if the leading coefficient is negative and that's a common factor, I'm going to take out a negative. But there's also more than that, so I should not just do that. Again, it's not wrong if you take out a positive and then you have a negative in the parentheses. I would rather have my negative on the outside. They all have two a's in common, and they all have two b's in common. So negative 5 divided by negative 5 is 1. I pulled out two a's. I have one a left. I have two b's left. Now here, I had a positive 10. I divided out a negative 5. I really have a negative 2 because a positive divided by a negative is a negative. And I have one b left over. And then I have plus 3a. Watch that again and make sure you understand, because remember, when I distribute, I have to get these numbers back. So negative 5 times 1 will give me negative 5. Negative 5 times negative 2 will give me plus 10. Negative 5 times positive 3 will give me negative 15. Alright, let's do one more GCF. Oh, geez. One more GCF. This is a good one. I think I'm on number 11. I'm not really sure. 3x cubed plus 18x squared minus 5x minus 25. Oh, that's a bad question. That's grouping. Sorry, we're not learning that. Sorry. You probably all wrote that down. My bad. There's no common factor there, and we're not going to talk about grouping. So, how about... I'll just make one up. 6x... Whoa! Hey, now. X squared y cubed z plus 4xy squared z cubed minus 10x cubed y squared. Okay, so look at the numbers first. They have a common factor of 2. X squared, x cubed, they all have one x in common. Basically, you're taking the lowest exponent out of all the variables that you have. Y to the third, y squared, that's y squared. But now here's the tricky part. This one has a z and this one has a z, but this one does not. So z is not a common factor because it has to be in every single term. So now we have 3xyz plus 2z cubed minus 5x squared. Okay, that's it for GCF. Make sure you always look for a GCF first. Now we're going to move on to difference of perfect squares. There's my difference of squares symbol. The most important part of this is you understand that it has to be difference. You cannot factor the sum of perfect squares, and I'll tell you why in a minute. But here's what happens. Try multiplying these two binomials. Practice that on your own. And then practice foiling this one. And then practice foiling this one and see what happens. Go ahead, do it now. Pause and foil. Okay, hopefully when you got done foiling this, your 8x is canceled out and you ended up with x squared minus 64. When you foiled this one, you ended up with a middle term of 8x. And when you foiled this one, you ended up with a middle term of negative 4x. So, this is when you multiply a sum, when you square a sum, basically. This is really saying x plus 4 squared. When you square a binomial, you always get a trinomial because of this middle term of 8x. When you square a binomial, which even if it's a minus sign, you always get a trinomial because of this middle term. The difference is when you multiply a positive by a negative, a positive 8 by a negative 8, you end up with this binomial. and they're both perfect squares. 64 is 8 times 8, x squared is x times x, and you always end up with a minus sign in here because these signs are different. If the signs are the same, you're going to get a middle term. So that's why we can factor the difference of perfect squares. So for instance, if I want to factor x squared minus 4, these are both perfect squares and it's a minus sign. So I can factor it into x plus 2, x minus 2. It's just the opposite sign with the square roots. Let's try another one. Y to the 4th minus 25. Y to the 4th is y squared times y squared plus minus 5 and 5. Now, you're saying, well, why can't I factor this? My question to you would be, how would you factor that? Do you think you would do y squared plus 5 times y squared plus 5? Because if you think that, you're wrong, because if you FOIL this out, you're going to end up with a middle term. And then some people say, well, then they're both minuses. Same thing. If you multiply something by itself, you end up with a middle term. So the only way to factor a binomial, two terms like this, two terms, is GCF or difference of squares. It has to be a minus sign in order to factor with perfect squares. Okay, now that I've talked about it, let's try some. First say, is there a GCF? Between 16 and 25, there's no GCF, and there's only a t term in one of them. Perfect square? Yes. Perfect square? Yes. Minus sign? Okay. Now I can factor into 4t plus 5, 4t minus 5. Okay. Let's try another one. This one gets people a lot, because they don't think of 1 as being a perfect square, but it is. Now, what happens when you have a GCF? Check this out. Notice here there's a GCF of x. When I factor out an x, I end up with, oh, this is cubed, sorry. I end up with a binomial. Sometimes your factoring will take 2 steps. You'll take out your GCF, and then whatever's left in the parentheses will also be factorable. Here we have difference of perfect squares. So 6 plus 7x, 6 minus 7x. And you have to write this x down here because I have to be able to multiply all of these things together and get what I started with. Let's try another one of those. See if you can factor that. Always look for a GCF first. Okay, so you have a GCF of what? 2. So you're left with 4x squared minus 49. Difference of perfect squares. 2x plus 7. 2x minus 7. Alright, one more and then I'll stop talking at you. Negative, this one's tricky, negative 80 x squared plus 45. Common factor here is 5. What if we factor out a negative 5? Let's see what happens. 5 goes into 80 16 times. And then I factor out a negative, so I have a negative in here, 9. That's the difference of perfect squares. 4x plus 3, 4x minus 3. Okay, there's your introduction to factoring. Hopefully you're going to be really good at GCF and difference of perfect squares factoring. See ya!